Welcome to Grateful, where we provide online, one-on-one, and small group SAT and ACT instruction to students all around the world. Right now, we're going through the October 2020 SAT Calculator Section 4 Math section. Let's go ahead and get started. Question 1 is a nice simple equation where we're just solving for a variable. So we can just divide both sides by 2 to get n by itself, and we get answer choice B for number 1. Question number 2 is asking us to create a proportion. If the ratio of trumpets to violins is 1 to 3, and there are 9 trumpets, then how many violins? So if you get into a tough situation where it's harder to keep track of the items in a proportion, you can always label them. So we have trumpets and violins, and we have the original ratio, and we have the question. So labeling your proportions like that can just make sure that you're keeping everything in line. Now we can cross multiply. 1 times x equals 3 times 9, and our answer is D for number 2. Question 3 is a multiple question scenario. It's just the beginning of one, and it doesn't explain overly well what an albedo is. So let's go ahead and just explain that. The question says, an albedo is the amount of light reflected from a surface divided by the amount of light falling on the surface. For people prepping for an SAT, that should sound really familiar. It's the part over the whole. We have the amount of the light that's reflected back divided by the total amount of light. So the part over the whole. We're going to go ahead and cover that more on question number 4, but for question number 3, we're being asked, for which of the following surfaces is the range of the albedos the greatest? So, for instance, for the meadow, we see a range, a difference of 0.08. For the crops, it's the same exact number, 0.08. For the dry soil, there's a difference of about 12 there, 0.12. And for the desert, we're seeing 0.13. So what I'm doing is just taking the difference between the maximum and minimum albedo. And then for snow, it's much greater. It's in the range of about 0.43. So the answer is snow, and that's answer choice D for number 3. Now question number 4 is getting a little bit more into the definition of what this albedo is, according to that description there for the questions, and it's the part over the whole, which is the amount of light that's reflected over the total amount of light that came in. So here we're being told that 1,000 watts of light came in, and what we're trying to find is the amount of light reflected. So if the albedo for the desert region is at its minimum, which is 0.26, then 0.26 is equal to the x over 1,000. It's the ratio of the amount reflected to the total amount of light. And by the way, at the maximum, it's 0.29. So at a minimum, 26% of the light is going to be reflected back, and at a max, 29% is going to be reflected. If you multiply both of those by 1,000, you get 260 for the minimum amount of light being reflected, and you get 290 for the maximum amount of light being reflected. So which of these numbers could be the amount of light being reflected? It's 275 because it's right in the middle between 260 and 290. So the answer for number 4 is A. And now we're looking at question number 5. This is a question on conditional probability or conditional fractions. And that's a situation where the question is asking you to shrink the pool of available data. So for regular probability, like for instance, if we were asked, what's the probability of selecting a female Alaskan Malamute, then that would be 2 out of the whole number, which is 20. But conditional probability, as opposed to regular probability, is the idea that we're shrinking the data. So here we're being asked about a male dog that received the vaccine during the month of July. And if we're narrowing it down to the male dogs, then we're only talking about this column right here. That means that we can basically cross out these other numbers. So if we're talking about the part over the whole, as we do in probability, then the whole is going to be the 10, the 6, and the 4. But the part of that, which comes from the Alaskan Malamute, is 6. It's just this part. So we can simplify that down to 3 over 5, which is 0.6. So the answer for number 5 is C. Question number 6 is asking us to find the equation of a line of best fit for this scatter plot. Now the line itself appears to be around here like that. So it looks to me to be a y equals mx plus b with a y-intercept somewhere around 7 and a slope somewhere around -1. And the reason for that is slope is rise over run as you go from left to right. So as we go from this point to this point, we are on our way down 7, so the rise is -7 for our rise over run. So that's -7, and then the run, the amount that it goes sideways, is +7. So -7 over 7, which is the same as -1. So in our y equals mx plus b, we've got -1 for the slope, 7 for the y-intercept, and that matches answer choice D for dog, because this is a y equals mx plus b, and one of the common things College Board will do is they'll reverse this to b plus mx, because it's just enough to throw a student off. But in any case, the answer for number 6 is D. Question number 7. The area of a square is 36 square inches. What's the length of one side of the square? Well, a square is really a special kind of rectangle, and the area of a rectangle is length times width. For a square, because the length and the width are by definition the same thing, we can call that side times side, or side squared. So side squared is equal to 36, and if we take this as its own equation, the next thing that we would want to do there is take the square root of both sides. And so square root of s squared becomes s. Square root of 36 is plus or minus 6. We're not caring about the minus side here because we're dealing with a geometric length, but you should always include it because the one time you don't could be the time you get burned. And the length of one side of the square is 6. So the answer for 7 is B. Going over to question 8 now. Question 8 is a seemingly easy question with a surprisingly tricky wording to it. We're being asked how many minutes did it take after the exercise period ended for the heart rate to return to the average heart rate before the exercise period began. So before the exercise period began, well, it began around 5 minutes. So before it began, we were right here. And reading the y-axis there, it seems like to me that the heart rate was around 69 beats per minute. Now, we're being asked how many minutes after the exercise ended did it take to return to that number. And the exercise period ended at 15 minutes, which we're seeing right over here. And so from 15 minutes, it took, let's say, about 10 minutes to get back to the same height where it was before. So that's about 24 minutes right there, so maybe about 9 minutes. And so that's why the answer for number 8 is A, 9. Question number 9 is asking us about exponential equations. So the basic format of an exponential equation is y equals a times b to the x. And you want to be really familiar with what each of these things means. So a is the starting amount, b is how it changes, x is the number of times that will happen. So we're seeing that there's a 200 here, a 1.02 here, and a 2 here. So it's starting at 200, it's changing at a rate of 1.02, and that's happening 2 times in 2 years. So we can kind of see that this is the number of years. And the 1.02 comes from the idea that if you start at 100% and increase by 2% from there, you would get to 102%. If you took away 2% from there, you'd get to 98%, and both are in decimal form. So in other words, if you were lowering something by 2%, you'd have to multiply by 0.98. If you were increasing something by 2%, you'd have to multiply it by 1.02. So this here is an increase of 2%. So what would happen if it were only after 1 year? Well, the number of times wouldn't be 2, it would be 1. So that's 200 times 1.02 to the first power, or just 1.02. And on a calculator, 200 times 1.02 is 204. But in any case, what we have here matches answer choice B for number 9. Question 10 is what we refer to as a corralling question. Now, by corralling, we mean you don't actually have to find x or y, but you can just take what's being given and churn it into what they're asking for. So if we start with 3x equals 8y, and we need this to churn into 40y, we can kind of observe that that means multiplying it by 5, because 8 times 5 is 40. And so if we're multiplying both sides by 5, then the 3x will become 15x, and so we have 40y equals 15x, and the answer for number 10 is D. Question number 11 is sort of a lengthy word problem scenario, and what you want to do on these is describe your variables. You need to be really certain about what each variable represents. The most important one here is n, which is the number of years after 2002. And the number of teachers is T of n, and the number of students is S of n. So the question is asking how many teachers in 2017. So if n is the number of years after 2002, that means that in 2017 we're 15 years after 2002 there, so n is 15. So the question is asking us to go over to the teacher formula, which is 80 plus n, and simply plug in 15. So that's 80 plus 15, and the answer for number 11 is C, 95. Question number 12 is asking us about the equation of a line. It's asking us for the graph of function s. Now what we should notice is that s is in the format of y equals b plus mx. In other words, it's a y equals mx plus b, which has just been churned around in a more unconventional order. We're seeing the y-intercept before we're seeing the slope expression. In any case, the y-intercept is the 1,280, and the slope is 30. And slope is your change in y over change in x. So that means that y is changing by 30 every time x is changing by 1, because any number is really itself over 1. So 30 becomes 30 over 1. So we can immediately get rid of answer choice C because it has the wrong y-intercept. Here, the y-intercept appears to be something around 0, but we need it to be 1,280. We can also get rid of answer choice B because it has a negative slope. And we clearly see here that the slope is the number 30. It's positive. And so we've gotten rid of 2 of the answer choices. And now, in order to pick between A and D, we can put the concept of slope to the test, because we're starting at 1,280 on both of these graphs, but if the slope is 30, then it means that over the course of 14 on the x-axis, that the y should be increasing by 30 by 14, because basically what we're saying is that the ratio of the increase in the y to the increase in the x is a ratio of 30 to 1. So if the x is increasing by 14, the y has to be increasing by 30 times 14, which is 420. So which graph between 0 and 14 seems to be increasing in the amount of around 400? Well, that's clearly answer choice A, because that one is going from around 1,300 to around 1,700, and so it's increasing by about 420, and the answer for 12 is A. Question 13 is asking us, when will the predicted number of teachers, which we know is T, the predicted number of teachers right here is T, when will that be greater than 90? So this is our predicted number of teachers, and that is supposed to be greater than 90. So with that inequality, we can go ahead and start solving, take away 80 from both sides, and n is greater than 10. Now, the greater than inequality means that it cannot be 10. It could be 10.00001, but it couldn't be 10. So we cannot go to 2012 because that's exactly 10 years after 2002, and that's the number that is exactly where our limit is. We can't go to that number. We could go to 2012 and just a couple of days or something like that, but that's not being offered to us. So we have to go over to 2013. That's the integer that is more than 10 years after 2002. So the answer for 13 is B. Question 14 is asking us to find a median. It's asking us to find the median length of the 9 turtles and tortoises, and then we're going to compare that to the length of the Aldabra giant tortoise. So what you want to be able to do on the SAT is find a median without necessarily having to write every number in order. Now the median, if you were to write every number in order, would be the middle number, or if you have an even number of numbers, it would be the average of the 2 middle numbers. But what you want to do on the SAT is be able to accomplish that without necessarily having to go through all the trouble of writing out all the numbers. And the way to do that is to start crossing off numbers in pairs. So we'll take the smallest number we see on that list and the largest number we see on that list, and the next smallest number and the next largest number, and keep going. Just keep track of the pairs because you need to know exactly where you are at the end. Then we have the lowest number we now see and the highest number we now see, and one more time, the lowest number and the highest number. So crossing them off in pairs like that leaves us with one single number. So I know, because we were crossing off pairs of 2, that there had to have been an odd number of numbers in the beginning. And that's the easier one because you just pick the middle number. If it were even, like I said a second ago, you would average the 2 middle numbers. So we have the median, which they asked us about, which is 140, and the Aldabra, which they referenced in the question, was the 150. So that's 150. Which is true about the Aldabra in relation to the median? Well, it's obviously 10 more. So it's 10 longer than the median length, and the answer for 14 is C. For question number 15, let's quickly do a little lesson on how to construct a box plot. Let's say that this is our data right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. If you're doing a box plot, first thing you want to do is find the median of everything, which is 7. So that's our median right there. What the median does is it splits the data into 2 sides, this group on the left and this group on the right. And what you want to do next is find the median of each of those subgroups. So for this one, it's the average of the 2 middle numbers, and that's 6.5. And for the set on the right, it's also the average of the 2 middle numbers, but that's a little easier to do because they're the same number. And we've already done everything you need to do to put a box plot together. We start at 5, we end at 10, our box starts at 6.5, and our box ends at 9, and the whisker is at 7. So now that we can see a sample of a box and whisker plot, we can maybe see what's the value, if anything, of a box and whisker plot, which is that it kind of shows you the way your data leans. Because the whisker is leaning to the left, it kind of means that our data is skewed in the smaller direction, as opposed to the larger. But in any case, to apply it to this question, the range is simply the distance between the highest and lowest numbers. So in data set A, the range is the distance between this number and this number, and for data set B, it's the distance between this number and this number. So what are those numbers? Counting down from 40, we have 40, 30, 20, 10. So one of the deceptive things about this question is that it's not actually starting at 0, it's starting at 10. And looking at data set B, here we have 120, 130, 140, 150, 160, so we're ending at 160. If the 2 data sets are combined into one data set, what's the range of the combined data set? It would go from 10 to 160, and that's a range of 150, and that's why the answer for number 15 is C. Question 16 is asking us about a basic exponential equation, and the format, like we said earlier in this video, is y equals a times b to the x. A is the starting amount, b is the way it changes, and x is the number of times. So in this situation, the bacteria is starting at 150,000, which it says right here, and it's doubling, which it says right here, and it says it doubles every hour right over here, and so x is just the number of hours, the number of times. And this exactly matches answer choice B for number 16. Question number 17 is asking us about the intersection between 2 functions. One thing we know is that this is a linear function Linear functions will have x and y to the first power, and this is a quadratic function, a parabola. And quadratics will have y to the first power and x to the second power. Now, anytime we're given multiple functions and asked for the solution, in this case, what could be the value of x, that's the solution. Anytime that happens, we're really being asked about an intersection. And for intersections, whenever possible, you want to get both equations in the y equals format and set them equal to each other, which is really easy to do here because they're both in the y equals format. So we have x minus 7 equals x plus 3 times x minus 7. Now, you could divide out an x minus 7 from each side, but you need to know that when you divide away an x from an equation, you're losing one of the answers. So if we were to do this, and we're kind of going to take a step back in a second, we would get 1 on the left and x plus 3 on the right. Taking away 3 from both sides, we'd get x equals negative 2. And notice that there is no negative 2. So we're losing a critical answer in this situation if we divide away something that involves an x. So instead of that, if we go back to the original equation, we have x minus 7 equals x plus 3 times x minus 7. And let's just go ahead and start solving. We'll FOIL out the right-hand side. X squared minus 7x plus 3x minus 21. And x minus 7 on this side. Combine some like terms. X squared minus 4x minus 21. And this is a quadratic, so when you notice that your equation that you're working with is a quadratic, that's your reminder to get it equal to 0 on one side. So let's go ahead and just take away x and add 7, take away x and add 7, and we'll get 0 equals x squared minus 5x minus 14. And now we're in a BC factoring situation because we have a b coefficient and a c coefficient, but we have no a coefficient. So BC factoring is super easy. We're looking for two numbers that add to b and multiply to c. So what two numbers add to negative 5 and multiply to negative 14? In this situation, you want to start with what it multiplies to. Believe it or not, there's an infinite number of integers, of pairs of integers that add to negative 5. But if we're looking for what two things multiply to negative 14, that would just basically be 14 and 1 or 2 and 7. So 2 and 7 works because we could have x minus 7 and x plus 2. And now that we have it factored, we can use the zero product rule because we have two things that multiply out to a product of 0, and that could only happen if one of them were 0. So we'll just go ahead and set each individual one equal to 0. And so we have here x equals 7 and here x equals negative 2. And so now we still have the solution of negative 2 that we arrived at earlier, but we also have the solution of 7, which is one of the answer choices. And so the answer for 17 is D. Question number 18 is asking us for a unit conversion. We're seeing that there are 320 million. I'll leave out the million because we can just add that back in later. And that's feet per second. Now, the reason we're not dealing with the millions is that we see million in the answer choices. So it's kind of just implied that everything we're doing right now is in the millions. But we're looking for yards per minute. So we can put in a unit conversion. These are chemistry-style unit conversions. These are empty parentheses here that are equal to the number 1. When we talk about the number 1, we're talking about fractions like 5 over 5 or 24 hours over 1 day. Because 24 hours in 1 day are the same thing, like 5 and 5, or even a plus b over a plus b. So there are essentially two main rules in all of algebra. You can do the same thing to both sides of an equation, or you can multiply something by a multiple of the number 1, which is what we're doing here. So here, let's multiply this by 60 seconds over 1 minute. Now, we could have multiplied by 60 seconds over 1 minute, or by 1 minute over 60 seconds. They're both equal to the number 1. But what we're trying to do is to get the seconds on the bottom to cancel against seconds on the top. And when you have a unit on the top and the bottom, they do cancel, just like a variable would. So right now, we have it in terms of feet per minute. But we need yards per minute, so let's convert the feet to yards. We have feet on the top, so it would be really useful to have feet on the bottom. So let's put feet on the bottom, and that's the idea that 1 yard is equal to 3 feet, as was told to us. And now the feet are canceling with feet, and we have yards on the top and minutes on the bottom. And so we can just divide that out. That'll be 320 times 60, and then divide that by 3. Now, let's say we were on the non-calculator section, even though, yes, we can use our calculator here, and we will, but a nice shortcut would be to simplify. We have a 60 on the top and a 3 on the bottom. If you divide them both by 3, you get 20 on top and 1 on the bottom. So now, instead of multiplying 320 by 60 and dividing by 3, we're simply multiplying 320 by 20, and that'll be our answer. And 320 times 20 is 6,400, and so that's 6,400 million, as we said, and the answer for number 18 is C. Question 19 is asking us about the attributes of a parabola. It's really important for a lot of questions on the SAT for you to be able to describe what the A, B, and C of a parabola of a quadratic equation represent. C is your y-intercept. And your y-intercept, as a general rule of thumb, is the idea that x equals 0. So just think about the idea that if x were 0 here, this would disappear and this would disappear, and we'd only have this. So what you have at the end is the y-intercept. It's what you get when x equals 0. The A coefficient is your vertical stretch and also your opening direction. The vertical stretch is a little less common in terms of how much the SAT asks about it, but you do need to know that something with a big A coefficient is going to look more like this, and something with a smaller A coefficient is going to look more like this. So that's very critical to know in some moments. But more important is the opening direction. If we have a positive A coefficient, it's going to open upward, and it's going to look more like a U. And a negative A coefficient, it's going to open downward, and it's going to look more like a mountain. So that's the value of knowing the A coefficient on a quadratic and turning our attention to the B coefficient. The B coefficient is your lateral movement. It's the thing that moves your parabola left or right on the XY axis. So if there's no B coefficient, one thing I know about my parabola is that it'll be symmetrical across the y-axis. It'll be somewhere here. We don't know where it would be in terms of height. We don't necessarily even know whether it would open upward or downward. But what we do know is that if B equals 0, it's centered on the y-axis, which I'm highlighting in green here. So that's everything you need to know about the A, B, and C of a quadratic equation. And let's apply that to this question. Here we're being asked, what is sort of the meaning of the 10,268? That's right here. According to our definition, that is the y-intercept. Now, what does that mean for us? This is a graph that we're told is representing the number of students. So in the y position is the number of students, and it's based on the t, which is the number of years. So we're talking about students per year. We've got a positive A coefficient, which means that it's got a positive y-intercept, and it's upward opening, so it looks kind of like a U. We don't really know whether it hits the x-axis or not, but generally speaking, that's what the graph looks like. So what is the 10,268? It's the y-intercept. It's this point right here. And how can we describe that? That's the starting number of students. And what do we mean by the starting number of students? The starting number is the y-intercept. It's the moment where x equals 0. So the number of students at the beginning of all of this, now t is not just years, it's years after 1969. So that means that at t equals 0, we're in the year 1969. So the answer for 19 is A. It's the number of students at the start of all of this, which is in 1969. Question number 20 is a very critical question on the SAT. It's asking us about translating slope. And some of the toughest questions you'll see come from this concept. The question is asking us to explain, literally, to explain what the slope is. And in a y equals mx plus b situation, in this situation it's y equals 44x plus 500, the slope will always be the change in y over the change in x. And the idea of translating slope is to set that up and then go ahead and describe what the y is and what the x is. And in this situation, y is going to be the total income from a product. And how do we know that? Because the question is telling us that the average customer rating is being used to estimate the total income. In other words, the customer rating is the input, the x, and the total income is the output, the y. So x in any situation is your independent variable. It's the thing that changes, like it or not. Y is the dependent variable. It's the thing that changes as a result of how x changes, and that's how this is being described to us. The thing that's changing no matter what is the average customer rating, and the result of that is the total income. So if we do change in y over change in x, we're saying that's the change in the total income over the change in x, which is the customer rating. So the slope, change in y over change in x, is the change in income over the change in rating. So that's 44 over 1, because it's the number 44, and any number is itself over 1. So the income is changing by 44 every time the rating changes by 1. Now, which answer says that to us? That's answer choice D. For every increase of 1 in the average customer rating, the income has this increase of 44. So the answer for 20 is D. Question 21 is asking us about the number of solutions for a linear system of equations. How do we know these are linear? Because they both have x and y to the first power. And when we're talking about the number of solutions in a linear situation only, that can happen three ways that we talk about a lot. They can hit once, that's the idea of one solution. They can hit never, that's the idea of no solutions. Or they can hit all the time. If you graph your lines and then you realize that they were the same line all along, that's the idea of having infinite solutions. And if you have one solution, that means that your slopes are definitely different, and so are your y-intercepts. Now, it is possible to have the same y-intercept, but it's not common. If you have one solution, that means that your slopes are the same, but your y-intercepts are definitely different, because we need two separate lines in order to have parallel lines. And if they're infinite solutions, that means that the slope and the y-intercept are both the same. And it makes sense because the graph is exactly the same. So of course the slope and y-intercept would be the same. Now, the way to use this information is to get them in a slope-intercept form. So we can't really do much with the equations of lines if we don't have them equal to y. So for the top equation, I'm going to take away 2x from both sides, and it gives you negative y is negative 2x plus 3, and then multiply both sides by 1, y equals 2x minus 3. For the bottom equation, we can take away 4x from both sides, negative y equals negative 4x plus 3, and go ahead and multiply them both by negative 1, and y equals positive 4x minus 3. So what do we have here? We have different slopes, which looks a lot like this one, and we have the same y-intercept. Now, we said that usually the y-intercepts are different for one solution, but they could be the same. It's just not so common. But once you have different slopes for two lines, you have one solution, and so the answer for 21 is B. Question 22 is asking us for the vertex formula of a parabola. So a parabola can show up in this format here, a x minus h squared plus k, and in this situation, h comma k is the set of coordinates for the vertex. So looking at this, we've got a positive x and a positive y for the vertex, and we know that because it's in the first quadrant. You know, this is the first quadrant, this is the second, this is the third, and this is the fourth. And in the first quadrant, x and y would be positive. In the third quadrant, x and y would be negative, and so on. So what's going to happen is that's actually going to show up as a negative because the formula itself has a negative sign right there. Another thing I'm noticing is that the equation looks like not like a U. It looks more like a mountain. And this is the idea that the A of an ABC parabola or of a parabola in vertex form, the A is negative when it looks like that, and the A is positive when it looks like this. So here we're going to want to see a negative A, so that matches two of the answer choices, and we've already narrowed out C, and D. But because the formula has a minus sign in it, we're going to kind of see a and x minus h squared. So whatever number we have right there is going to look negative, and that's just from the formula. It's not from the actual point. So if you have a positive x value, it's going to look like this. But then we're going to have a positive number off to the side, and we're hearing that a, b, and c are all positive. So now if the vertex were b comma c both positive, then we have our negative a because it's a downward opening parabola, and we have x minus the b of the vertex. And the reason this is minus is because the formula itself has a negative in it, so we're going to keep our negative right there. And that's squared plus the other coordinate of the vertex. So with b and c positive and with the parabola opening downward, it's going to look like this, and that matches answer choice A for number 22. Question 23 is asking us about the idea of a difference of squares where there really is none. Now what I mean by that is if you had a squared minus b squared, that would factor to a plus b times a minus b. And first let's just practice that a little. That's two perfect squares, and it factors to the square root of each piece with a plus and a minus sign in between. So for instance, if we had x squared minus 25, that factors to the square root of each piece, which would be x plus 5 times x minus 5. So to use another example, if we had 25b squared minus 36d squared, that still factors to the square root of each piece. So 5b plus 6d and 5b minus 6d. And last but not least, if we had something that maybe isn't really a perfect square, if we had a squared minus 7 along the same format, that would factor to a plus the square root of 7 and a minus the square root of 7. Because what we've been doing all this time is taking the square root. So the square root of a squared is still a, but because 7 is not a perfect square, we can write the square root of 7 as literally that, square root of 7. So that's kind of what we need to be sharp on in order to handle question 23, because we can factor the numerator to x plus the square root of 2 and x minus the square root of 2, and the denominator has x minus the square root of 2 already. So now we have a situation where we can cancel from the numerator and denominator, and it leaves us with x plus the square root of 2, which is answer choice D for number 23. Going on to question 24 now, it's asking us how to apply a percent increase or a percent decrease. And the idea here is that when we're dealing with percents, we always start with 100%. If we were to increase by 5%, it would take us to 105%. If we were to decrease by 5%, it would take us to 95%. So that's the idea of the increase, and this is the idea of the decrease. But in order to use these, we have to move the decimal 2 spaces over. So you'd get 0.95 or 1.05. So when R is increased by 5%, then that's the idea of multiplying R by 1.05. And so the answer for 24 is C. Question 25 is asking us for the median when given a frequency chart. And you want to be really careful with these. They're not overly difficult, but as a tutor I can tell you that students do get them wrong the majority of the time. So if we're looking at the values, let's say on the right column, if we count from here downward, the important question is how many numbers did we just count? And a lot of students would tell me we just counted 3 numbers, but the truth is we just counted 7 numbers. And that's because the frequency is a measure of how many numbers there are. So in other words, there's 1 1, there are 4 2s, and there are 2 3s. So we could kind of just imagine laying this out. You never want to do this on a test because the whole point is to do what you can do as quickly and efficiently as possible. But we have the number 2 showing up 4 times. We have the number 3 showing up 2 times. The number 4 showing up 3 times. And then the number 5 showing up 7 times. 1, 2, 3, 4, 5, 6, 7. So this is what the numbers really look like, but the trick is to be able to understand this without having to go through all that work. Now if we're looking for 7 numbers from the bottom coming up, then we can just count these 7 numbers. So right now we have 7 numbers on one side and 7 on the other, and that means that our median our middle area is right here. It's these three numbers. And what are those three numbers? They're the number 4. So what is the median? It's the 4. Now, in order to get a better image of what we just did, when we counted these 7 numbers, we counted the 1s, the 2s, and the 3s, so it was these numbers. Then, when we counted these 7 numbers, those are just the 5s. Those were these numbers here. So we had an equal number of numbers on the left, as we did on the right, and these 3 4s right here are in the middle, and they are the median. The true median is this number 4, but since they're all 4s, it really doesn't matter, and the answer for 25 is C. Question number 26 is a really important unit conversion question, and I've been seeing more of these questions as we've seen more recent SATs. And the idea here is that there are 60,000 gallons of fuel, and the plane is going to use or lose 5 gallons per mile flown. Now the problem is that we have conflicting units right now, so we can't really truly subtract. But we can use unit conversions to fix the difference. The plane is traveling at 550 miles. It's covering 550 miles in 1 hour. So if we let the mile unit cancel out, because we've got 1 on the top and 1 on the bottom, this is leaving us with gallons per hour. So we still don't have matching units because the first unit is just gallons. Now if we go to the third one, the only thing we have in this problem that we haven't used yet is the idea that there are T hours. And that's perfect because that's going to give us hours on the top, which we can cancel against the hours on the bottom. And so if those two things cancel out, it leaves us with only the gallons. And that matches the gallons we had before. So now we can go ahead and subtract them. We have 60,000 gallons minus whatever you get for 5 times 550 times T. And that multiplies out to 2,750. So the equation is A is equal to 60,000 minus 2,750 T. And that's answer choice D for number 26. Question 27 is something that has a really important reference that you should be able to catch on any SAT that you do. The idea here is that we have a quadratic equation and we're talking about the number of solutions for that equation. And when you're talking about the number of solutions for a quadratic, you're talking about the discriminant. Now the idea of the discriminant is the idea that if we use the quadratic formula to solve an equation like this, which is totally allowed, then there are 3 ways it could work out. I'm just going to make up fake numbers to prove that point. We could have 2 plus or minus square root of 4 over 3. Now I'm just making these numbers up. They have nothing to do with the question. 2 plus or minus square root of 0 over 3, and 2 plus or minus square root of negative 4 over 3. Now the discriminant is this red part, the part under the radical, the 4, the 0, or the negative 4. And depending on the sign of the discriminant, whether it's positive, 0, or negative, that impacts the number of answers, because right here we would be adding 2 and taking away 2 because the square root of 4 is 2. So we would have 4/3 and 0 as our 2 answers. And so when the discriminant, the b squared minus 4ac, when that part is positive, you end up with 2 solutions. Here, if the discriminant is 0, we're not really adding or taking away anything because 0 is, by definition, nothing. So the answer would just be 2/3 and there would be 1 solution. And right here, if we have a negative discriminant, well, this is violating one of the rules of math. There really are 2 rules for undefined values. You can't have a negative under a radical, and that's an even radical, and you can't have a 0 in a denominator. So here we have a negative under a radical, and that's the proverbial no solutions. So when this question tells us that we have a quadratic with no solutions, what the SAT is really telling us is that b squared minus 4ac is, by definition, negative. And so we can plug in the a, b, and c of this quadratic. Now one thing to watch out for on other tests is that the letters a, b, and c can kind of be put in the wrong place. So for instance, the 5, the c, well, another question might call that A because it's incredibly confusing to have the thing that we think of as an A be in the spot of a C. But here, they're playing nice and they're making B, B, which is great, but b squared minus 4ac would be their b squared minus 4 times 3 times 5, and that's less than 0, so we'll just start solving. This is minus 60 here when you multiply these numbers, and you can add 60 to both sides, so b squared is less than 60, and that matches with answer choice A for number 27.
Question 28 is a really challenging question because it's so different from a lot of the other questions we've seen on the SAT Section 4. We know we have two lines and they're perpendicular and they intersect at the origin. Line R passes through 1K. And what we need to realize about this is that we actually have 2 points. We have the origin that they both pass through and we have 1K. So for line R, we can actually get an expression for the slope because it's y2 minus y1 over x2 minus x1. And so if we take 1k and 0, 0, we can say that that's k minus 0 over 1 minus 0, which is k over 1, or just k. Now, if line Q is perpendicular to that, then that means that the slope is going to be the negative reciprocal. It's going to be negative 1 over k. Now, line Q passes through 0, 0. So this can be thought of as the y-intercept. The y-intercept is the place where x is 0. So if we do it as a y equals mx plus b, the m is negative 1 over k, and the b is 0. And so we have y equals negative 1 over kx, which is mathematically equivalent to negative x over k, so the answer for 28 is B. For question 29, we're dealing with the area of a shaded region, and the area of a shaded region is going to be the area of the outer whole region minus the area of the excluded piece. So for us, that means the area of the pizza slice minus the area of the equilateral triangle inside of that pizza slice. So the pizza slice is pretty easy to find. It's 1/6 of the area of the circle, which is pi r squared, so pi times 4 squared. Now how do we know it was 1/6? Because it's 60 degrees out of the whole 360 degrees of the circle. And now we're moving on to the area of the equilateral triangle, AOB. Now, finding the area of an equilateral triangle is a very important SAT skill. Not only will you have to do exactly that here and there, but also it involves lots of other skills that are important in different ways. Generally, working with 30, 60, 90 special right triangles. So if we have an equilateral triangle, it'll also be equiangular. So the angles will be 60, 60, and 60. So splitting the top one, we'll get 30 and 30. And the 30, 60, 90 triangle ratio is on the formula sheet for the SAT, but really you should know it so well you shouldn't have to look at that. So it's x 2x, x root 3, and x goes across from the 30, and x root 3 goes across from the 60. And if the radius is 4, then that means that this 2x equals 4. Therefore, the x is equal to 2, and x root 3 would be 2 root 3. So getting the area of this whole triangle now, 1/2 times base times height, and the base is 4 and the height is 2 root 3. And so multiplying that out, you have 1/2 times 4 times 2, and all of that comes out to 4. So we'll have 4 root 3 right there, and that's the area of the equilateral triangle, so minus 4 root 3. Now we just have to get some work to make it look like one of these answer choices. So we can go ahead and square the 4, so 1/6 times pi times 16 minus 4 root 3, and 1/6 times 16, we can just multiply that and make it look like 16 over 6, which is 8 over 3, so 8 over 3 pi minus 4 root 3. And now what we need are some common denominators. We can multiply by 3 over 3, and so we'll have 8 over 3 pi minus 12 root 3 over 3. And so we have a common factor now of 1/3 that we can factor out. We can take out a 1/3, and that would actually leave us with 8 pi minus 12 root 3. And it's not over 3 because we factored out the 1/3 from both of those terms. And this exactly matches answer choice D for number 29. On question number 30, we just need to stay well organized regarding the different things they're talking about. So they're talking about students who have one sibling, students who have two or more siblings, and students who have no siblings. So we're hearing that the students who have one sibling is 3 times more than, or 3 times the number of students, n, who have 2 or more. So the students who have 2 or more is n, the students with 1 is 3 times that. And no siblings is 6. So if there are 30 students altogether, we could say all 3 of those things add up to 30. And we can just go ahead and start simplifying from there, take away 6 from both sides, and divide by 4, and we get n equals 6. And that would be the way to solve the question, but we already had the equation that mattered right here. 4n plus 6 equals 30, and the answer for number 30 is C. Question number 31 is asking for how many of the 10 airports was the percent of flights with delayed arrivals. By the way, that's just this title here. So for how many of the 10 airports was the Y value, which is, you know, that long title we have right there, the Y value is less than that predicted by the line of best fit. So the actual needs to be less than the line. And how many times did that happen? The actual would be the points, by the way. So how many times are the points below the line? 1, 2, 3, 4, 5, 6. For how many of the 10 was it there? For 6 of the 10, and the answer for 31 is a nice and easy 6. Question 32 is giving us a congruency statement. It's telling us that the triangles are congruent, and they're telling us that angle A corresponds to angle E. So if they're congruent and those two correspond, then this is also 65 here. And we're being told that B corresponds to D. So these two correspond to each other, which means that this is 75. And therefore, the third angle should also correspond, so this should be 40. And what's the measure of angle GCF? That starts at the G, goes to C, and passes through F. So we're talking right now about this angle here. And so within this whole triangle here, we've got 2 of the angles, 40 and 40. And then we've got the one that we're looking for, which we'll call theta there. And the 3 angles of a triangle add to 180. So 80 plus theta equals 180. And theta equals 100 degrees, and so the answer for 32 is 100. Question 33 is giving us a line and telling us that it has a y equals mx plus b format to it. And what's the value of m? M is just the slope. So using the 2 points that they gave us, slope is rise over run as you go from left to right. So going from point A to point B, we're rising by 1, 2, 3. And we're running by 1, 2, so the slope is 3 over 2 for number 33. Question 34 is a question on conditional probability or conditional fractions. When they ask us what fraction of the cornfields where an eye spot was observed needed something, well, they're telling us only look at where the eye spot was observed. So that's these 30 and these 10, so there's 40 of them altogether. By doing that, the question is basically telling you to ignore all of these numbers. So if we arrange the part over the whole for the area we're talking about, the area we're talking about has a total of 40 in it, and 30 of them needed fungicide. And so that simplifies to 3/4, and the answer to question 34 is just that, 3/4. Question 35, believe it or not, is asking us for a slope of, maybe you can think of it as a line of best fit, because they're asking about the average rate of change from 1916 to 1926, and that's just this portion of the line. So slope is your change in y over your change in x, and the y is changing by whatever you get for the difference between 421,000 and 397,000, and the x is changing by whatever the difference is between 1926 and 1916, which is a nice and easy 10. So 421,000 minus 397,000 is 24,000, and divided by 10, that'll take away one of the zeros, so it'll be 2,400 over 1, and that's our answer, 2,400. Going to question 36 now, we have the number of houses that were painted in July, and we have the number that were painted in August, and July is 20, and August is 20% more than that. So 20% more, that would be 1.2 times the 20. And the reason is, with percents, you're always starting at 100. If I added 20, I would get to 120. If I took away 20, I would get to 80. And you put them both in decimal form, and you get 1.2 or 0.8. So if I add 20% to something, it's the same as multiplying it by 1.2. And if I take away 20% from the same thing, it's like multiplying it by 0.8. So we multiplied it by 1.2, and we get 24 for that. So what fraction of the total number of houses they painted in July and August? Well, that's 44. And what fraction of those were painted in August? That's 24. So we can simplify that. 12 over 22, which becomes 6 over 11. And that's our answer for 36, 6 over 11. Question 37 is giving us the price of a car before and after, and asking us by what percent did it decrease. The formula for percent change is it's the change over the original, and so we can just apply that here. The change is whatever you get when you go from 12,000 to 9,600, and we're dividing that by the original, which was 12,000. So let's calculate that out. So 12,000 minus 9,600 is 2,400, and we're dividing that by 12,000, and you get 0.2, which is 0.20, so that represents a 20% change. Because 0.20 is in decimal form, you need to move the decimal over 2 spaces to get it into percent form, and that's our answer for number 37, 20. Question 38 is a really interesting question because on the one hand, it's a system of linear equations and you can go through the trouble of solving for t and u. On the other hand, you can notice that these things are all identical and these things are all identical. And so what that means is we can substitute in and call this a plus b equals 37 and a minus b equals 19. And look how much easier that is. We're basically calling every blue thing an a and every purple thing a b. Set up like this, it just kind of solves itself. If you add straight down, you get 2a equals 56 divided by 2, you get a equals 28. And if a plus b is 37, then b has to equal 9, so that 28 plus 9 can equal 37. So now, we just found out that the blue thing has a value of 28, the purple thing has a value of 9, and what is the product of those two? 28 times 9 equals 252, and that's our answer for number 38. Thanks so much for joining us as we've gone through the October 2020 Calculator Math section. We tutor students online, one-on-one and small group, in SAT and ACT, and we work with students all around the world. And we'd be happy to work with you and help you to do your very best in pursuing your college dreams. If you're interested, go ahead and reach out and have a wonderful day.